for some reason we just can't see.
Look, he says here, I like your idea. So why does he delay?
You see, Kaluza had sent his idea about an additional spatial dimension to Albert Einstein. And although Einstein was initially enthusiastic, he then seemed to waver and for 2 years held up publication of Kaluza's paper.
Eventually, Kaluza's paper was published after Einstein decided extra dimensions were his cup of tea. Here's the idea. In 1916, Einstein showed that gravity is nothing but warps and ripples in the 4 familiar dimensions of space and time. Just 3 years later, Kaluza proposed that electromagnetism might also be ripples. But for that to be true, Kaluza needed a place for those ripples to occur. So Kaluza proposed an additional hidden dimension of space.
But if Kaluza was right, where is this extra dimension? And what would extra dimensions look like? Can we even begin to imagine them? Well, building upon Kaluza's work, the Swedish physicist Oskar Klein suggested an unusual answer.
Take a look at the cables supporting that traffic light. From this far away, I can't see that they have any thickness. Each one looks like a line, something with only a single dimension. But suppose we could explore one of these cables way up close, like from the point of view of an ant. Now, a second dimension, which wraps around the cable, becomes visible. From its point of view, the ant can move forwards and backwards, and it can also move clockwise and counterclockwise.
So, dimensions can come in 2 varieties. They can be long and unfurled, like the length of the cable, but they can also be tiny and curled up, like the circular direction that wraps around it. Kaluza and Klein made the wild suggestion that the fabric of our universe might be kind of like the surface of the cable, having both big extended dimensions, the 3 that we know about, but also tiny curled up dimensions, curled up so tiny, billions of times smaller than even a single atom, that we just can't see them. And so our perception that we live in a universe with 3 spatial dimensions may not be correct after all. We really may live in a universe with more dimensions than meet the eye.
So what would these extra dimensions look like? Kaluza and Klein proposed that if we could shrink down billions of times, we'd find one extra, tiny, curled-up dimension located at every point in space. And just the way an ant can explore the circular dimension that wraps around a traffic light cable, in theory, an ant that is billions of times smaller could also explore this tiny, curled-up circular dimension. This idea that extra dimensions exist all around us lies at the heart of string theory. In fact, the mathematics of string theory demand not 1, but 6 extra dimensions, twisted and curled into complex little shapes that might look something like this.
If string theory is right, we would have to admit that there are really more dimensions out there. And I find that completely mind-blowing.
If I take the theory as we have it now literally, I would conclude that the extra dimensions really exist. They're part of nature.
When we talk about extra dimensions, we literally mean extra dimensions of space that are the same as the dimensions of space that we see around us. And the only difference between them has to do with their shape.
But how could these tiny extra dimensions, curled up into such peculiar shapes, have any effect on our everyday world? Well, according to string theory, shape is everything. Because of its shape, a French horn can produce dozens of different notes. When you press one of the keys, You change the note because you change the shape of the space inside the horn where the air resonates. And we think the curled-up spatial dimensions in string theory work in a similar way. If we could shrink down small enough to fly into one of these tiny, six-dimensional shapes predicted by string theory, we would see how the extra dimensions are twisted and curled back on each other, influencing how strings, the fundamental ingredients of our universe, move and vibrate. And this could be the key to solving one of nature's most profound mysteries. You see, our universe is kind of like a finely tuned machine.
Scientists have found that there are about 20 numbers, 20 fundamental constants of nature that give the universe the characteristics we see today.
These are numbers like how much an electron weighs, the strength of gravity, the electromagnetic force, and the strong and weak forces. Now, as long as we set the dials on our universe machine to precisely the right values for each of these 20 numbers, the machine produces the universe we know and love.
But if we change the numbers by adjusting the settings on this machine even a little bit, the consequences are dramatic. For example, if I increase the strength of the electromagnetic force, atoms repel one another more strongly, so the nuclear furnaces that make stars shine break down. The stars, including our sun, fizzle out, and the universe as we know it disappears.
So, what exactly in nature sets the values of these 20 constants so precisely? Well, the answer could be the extra dimensions in string theory. That is, the tiny, curled-up six-dimensional shapes predicted by the theory cause one string to vibrate in precisely the right way to produce what we see as a photon, and another string to vibrate in a different way, producing an electron. So, according to string theory, these minuscule, extra-dimensional shapes really may determine all the constants of nature, keeping the cosmic symphony of strings in tune. By the mid-1980s, string theory looked unstoppable. But behind the scenes, the theory was in tangles. Over the years, string theorists had been so successful that they had constructed not one, but 5 different versions of the theory. Each was built on strings and extra dimensions, but in detail, the 5 theories were not in harmony. In some versions, strings were open-ended strands. In others, they were closed loops. At first glance, a couple of versions even required 26 dimensions. All 5 versions appeared equally valid, but which one was describing our universe?
This was kind of an embarrassment for string theorists because on the one hand we wanted to say that this might be it, the final description of the universe, but then in the next breath we had to say, and it comes in 5 flavors, 5 variations. Now, there's one universe, you expect there to be one theory, not 5. So this is an example where more is definitely less.
One attitude that people who didn't like string theory could take was, well, you have 5 theories, so it's not unique.
This was a peculiar state of affairs because we were looking just to describe one theory of nature and not 5.
If there's 5 of them, well, maybe there's smart enough people would find 20 of them, or maybe there's an infinite number of them, and you're back to just searching around at random for theories of the world.
Maybe one of these 5 string theories is describing our universe. On the other hand, which one and why? What are the other ones good for?
But having 5 string theories, even though it's big progress, raises the obvious question: if one of those theories describes our universe, then who lives in the other 4 worlds?
String theory seemed to be losing steam once again. And frustrated by a lack of progress, many physicists abandoned the field. Will string theory prove to be a theory of everything? Or will it unravel into a theory of nothing?